Okay, let's unpack this. You sent over the Ethereum white paper. Foundational stuff.
Absolutely. Vitalik Buterin's vision back then, it really set the stage for so much.
Right. So for this deep dive, the mission is really to pull out the core ideas. How Ethereum took Bitcoin's foundation and just went somewhere totally new.
Exactly. Bitcoin gave us that decentralized ledger, proof of work, solving the double spend. Crucial first steps.
Crucial, yeah. But it had limits for building on top of it, didn't it?
Definitely. The scripting was intentionally simple. Good for security, but limited.
Yeah, I remember reading about that, like no loops. That's the Turing-completeness thing.
That's a big one. No loops. Also, value blindness couldn't easily check transaction amounts within the script itself. And no internal state for contracts to remember things step by step.
So you couldn't build complex applications easily. You'd hit a wall pretty fast.
Precisely.
Right.
And that's the gap Ethereum jumped into. It built a blockchain with the built-in Turing-complete language.
Okay, so not just a ledger for money, but like a global computer you could program.
That's a great way to put it. You can write contracts with pretty much any rules, any logic you can think of.
And these contracts aren't just bits of code sitting there.
No, they're more active. Ethereum introduced different accounts, the ones people control directly, and contract accounts.
Contract accounts. So the code has its own address.
Yeah, and its own balance, its own storage. And they can send and receive messages, which can carry data, trigger functions. They can even call other contracts.
Ah, so they become sort of first-class citizens on the network. They can interact.
Exactly. That interactivity is key. Think about it. The white paper mentions writing a Namecoin-like domain system in just like 2 lines of code.
Wow. Okay, so that simplicity enables complexity. What kind of apps did this unleash? Beyond just tokens, I mean.
Oh, all sorts. Financial derivatives for sure. Imagine contracts that automatically pay out based on external data, like a price feed for a commodity.
Automated hedging, things like that.
Yep. And then you get into decentralized file storage users renting out hard drive space directly, and of course, DAOs.
Decentralized autonomous organizations. That still feels pretty cutting edge.
It was radical. Organizations governed by code, by rules baked into the blockchain itself. Less need for traditional management structures, potentially.
Okay, but building this super powerful open system, it sounds risky too. Like that Turing completeness will stop someone writing a program that just runs forever and clogs everything.
Good question. That's where the gas mechanism comes in. It's fundamental.
Gas, right, like fuel.
Exactly like fuel. Every single computational step a contract performs costs a tiny amount of gas. You have to specify upfront with your transaction the maximum gas you're willing to spend.
So you set a budget.
You set a budget. If the code runs out of gas before it finishes, everything it did gets rolled back, reverted, but you still pay the fee for the computation used.
Ah, so it protects the network. Malicious code or even just buggy code can't run away indefinitely.
Precisely. It puts an economic limit on computation.
Okay, that makes sense. What about the other big blockchain issue, scalability? Every node processing every transaction sounds heavy.
It is a challenge. Ethereum tackled part of this with its state storage. It uses something called a Patricia tree. It's a very efficient data structure.
How does that help?
Well, instead of copying huge chunks of data, each block only needs to change small parts of this tree structure. It saves a lot of space and makes looking up account balances or contract states much faster.
Okay, clever storage. And it helps with verifying things too.
Yeah, it enables verification protocols, so even light nodes that don't store the whole blockchain can still effectively check if blocks are valid, helping maintain decentralization.
And mining. Bitcoin went the way of ASICs, those specialized chips. Did Ethereum try something different?
It did, at least initially. The idea was to use a mining algorithm that was memory hard. It required access to significant chunks of the blockchain data, making it harder to build super specialized, efficient hardware like ASICs.
So trying to keep mining more accessible, more decentralized.
That was the goal, yeah. To foster more egalitarian participation and resist the kind of centralization seen with Bitcoin ASICs.
So pulling it all together, Ethereum wasn't just another coin. It was conceived as this generalized foundation.
Absolutely. A foundational layer for arbitrary state transitions, as the paper puts it, combining blockchain, scripting, everything into one platform.
So it really invited the question, for you listening, what could you build on a platform designed for basically any programmable logic?
Exactly. It's about adding this trustless economic layer to potentially countless applications far beyond just finance. It's a different way to think about building decentralized systems.